Cancel live. Excellent. So if I wanted to share this, invite people. Excellent. So, in the interest of time, and hopefully there will be people who arrive into the video soon, I am going to spend this time doing a friction log for tf.image. And what I will be doing for this full hour is sort of tracking things that are difficult to use, testing functionality for TensorFlow 2.0 that wasn't existent in TensorFlow 1.12, and also probably cursing quite a bit, because the reason why I chose tf.image in order to start as the first module in this series was because it seemed to be a little bit more piecemeal than other bits of the TensorFlow API. tf.keras is fantastic, and it feels very consistent, very coherent, like it was well designed and it was very carefully thought out. tf.keras is phenomenal. tf.image feels a little bit less well designed. So hopefully this will be kind of an interesting dive into what's great about it, if there are great things, and what's a little bit wondrous otherwise. So it looks like we have a few people who have joined. I see Akash and Joseph. Excellent. So howdy everybody who's here. I'll hopefully be able to take a look at the chat window as I'm doing this, but I'm also working from my laptop. So if anybody was ever sort of curious about what the Google AI library looks like, kind of pretty. And hello to everyone on this beautiful Saturday night. Rad. Okay, so with that, let's get started with a screen share. My entire screen and share. Wow, that's screenception. And that is a little bit better. Cool. So here we have the API documentation for TensorFlow 1.12. If we bounce over to the Python piece, we can see that tf.image has quite a few ops, and they aren't exactly the most intuitively named, right? So we have some resize operations, we have random saturation, random contrast, extract glimpse, some decode options, and then also some adjustments that can be made for brightness and contrast and hue and saturation. So this is great, but it's also not exactly, like I said, the most intuitive thing that you would be able to use for whatever operation that you're going to try. For the TensorFlow 2.0 API docs, let's take a look at tf.image. kind of the same thing. It feels like a big basket filled with just random operations. No really consistent bucketization of each one of the bits of functionality. Ideally, you would have, a group of operations that are kind of clustered together that would take care of cropping, a group that would take care of doing these image adjustments, a group that would take care of doing maybe the image resizes, and then another one that would be in charge of doing the adjustments to hues. So that's problematic. And for the exploration that we'll be doing tonight, I think I'll probably be concentrating on those buckets, right? So image resizing, flipping, rotating, and transposing, converting between color spaces, making those other image adjustments, and then also doing some cropping. As I said, since life is about variety, and also because this isn't potentially one of the most exciting ways that you could be spending a Saturday night, we're going to be spending it looking at pictures of Jeff Goldblum. So let's install TensorFlow 2.0. Hopefully it'll be pretty quick. I'm using my personal version of Google Colab. So this is this notebook will be shared with you all afterwards if you have any interest in taking a look at it. And then also everything that we do tonight is super duper open source. So we should be able to replicate as needed. TensorFlow 2.0 has been installed, clearing the output so it looks a little bit friendlier. We're also going to import a few other usual suspects from the Python ecosystem: matplotlib, scikit-image, and then of course the version of TensorFlow that we just downloaded. And we can double check to see that it's the 2.0 version. So dev 2.0, rock and roll. And the 4 Jeff Goldblums, because Science-y Jeff Goldblum is super duper underappreciated as a character. Ian Malcolm, Sidney Zwiebel, Seth Brundle, and David Levinson. So if you're a movie aficionado, you'll understand what that means. And then also you can follow the links. And let's see how these guys look. And these are just images that I'd selected randomly ahead of time. So Jurassic Park, Buckaroo Banzai, Fly, and Independence Day. Beautiful. Cool. So starting with image resizing. The image resize ops accept input images as tensors of a lot of different types. So PNGs, JPEGs, and they always output resized images as float 32 tensors. If you've had experience with matplotlib, you know that matplotlib hates plotting 32 floats. So it's just checking to make sure that the extensions are good. Yeah, so PNGs and JPEGs. Looks like we're good to go there. The convenience function supports 4D and 3D tensors. Good. So if we wanted to check the shapes for the tensors that we just created, I could do Jeff dot get shape for Jeff and Jeffs. And the Jeffs list is just that collection of converted to tensor images that we created up top. So let's see what this looks like. We have some tensor shapes. And then you could also, if that's not really your speed, you could do something like tf.shape, Jeff, for Jeff in Jeffs. And you could get a little bit more information about those tensors. So it looks like they're consistent shape, consistent type. We have some wonkiness with the channels for the PNG, but it looks like everything is pretty consistent and everything's been ingested the way that it's supposed to. Awesome. So if we wanted to start resizing, if you'd used TensorFlow 1.12, or previous versions of TensorFlow, you knew that it had kind of a wonky symbol name and that it was called tf.image.resize images. This has been changed to be tf.image.resize, which makes a little bit more sense. And it encompasses resize area, resize by cubic, resize by linear, and resize nearest neighbor. You would just change sort of the arguments that you have within tf.image.resize in order to support that. So what does that look like, right? So if I wanted to have, so for example, tf.image.resize, and let's take a look at that first, Jeff. Change it to be whatever, 190 by 400 pixels. Let's see what this looks like. Cool. So it gives me back, again, float 32, an array, and a sort of new version of that photo that we were looking at before. And you could say like, oh, well, that's great. Those are a lot of numbers. What does it actually look like? So if, you wanted to do, as any good Python developer, plot.imshow, and for matplotlib, that looks kind of wonky, right? So ideally, what would have happened here is that we would have had an image spit back at us that looks like a slightly distorted view of the second image from Buckaroo Banzai, right? This does not look like that. It looks like maybe it plucked out some bits of Jeff's hair. It had, kind of other aspects of the background. But for the most part, that looks pretty bad. And it's mostly due to the type of data that we'd pulled in from our tensor. So if we wanted to recast this guy, right? So to accept an int as opposed to the float that we had before, what you could do is tf.dtypes.cast. And then let's see. So tf.dtypes.cast, and then dtype, I think this is right, dtype.tf.int32. Maybe not. I love that Colab barks at me if I have a parentheses located in the wrong place, or it highlights, or it makes it red. Red is sort of understandable. Beautiful. Okay, except they're the axes, and that's ugly, and make it not odd, not odd. Off. There we go. Cool. So that's better. So yeah, as I mentioned before, what you have here is a slightly distorted view of Jeff Goldblum, and it's mostly because we resized without kind of preserving the original dimensions of the image, right? So we took the we made the sort of height half the size that it was, and then just did not kept the width a little bit larger than it should be. Cool. So that worked. I really didn't like that. IMShow kind of barked at the 32-bit floats, but for the most part, that was pretty painless. So let's go into this. Let's try another thing. Let's do this trying a resize method. Right, so copy paste to this guy. And I mentioned before that by cubic, by linear, nearest neighbor, and area got changed into just another argument for this image resize shenanigans. Let's take a look at what that would be. So 2.0 docs, resize method. And it look okay, cool. So the resize method default is bilinear. You also have the option of doing nearest neighbor, by cubic, and area. Rad. Okay, cool. So let's do the nearest neighbor. Let's see if it, and it should just be this resize method bilinear. Go over here. right after this guy. Method equals resize method dot nearest neighbor. I wish there was autocomplete. And Brad. Okay. Resize method is not defined. That doesn't sound good. I wonder if I have to prepend it with tf.image. Let's try that. Brawler. Okay, cool. So apparently, it looks like for previous versions of TensorFlow, you could just get away with using this guy whenever you say method equals. For this one, you're going to have to prepend it with tf.image. And I wonder if that has anything to do with some of the renames that have happened. But regardless, things look pretty good for nearest neighbor. Let's try bicubic. Works there too. But with kind of another interesting error message about clipping the input data. The image looks intuitively about the same. And then what was the other one? Area? Let's try. Huh. So this is interesting. That's interesting. So, okay. So area looks like it's changed the resize a little bit. And I would be interested to see kind of the numeric differences between this guy and this guy. It looks, if just based on vision, right? It looks like there were a couple of white dots up here that aren't quite as bright down there. Cool. So I should make a note of that. Add some text, move it up. Make a note to check to see numeric difference between area and nearest neighbor bilinear. Rad. I also wonder if there's an image op that would be able to give me that difference. And again, PSNR. How is that an intuitive name, right? It returns the peak signal to noise between A and B. SSIM computes SSIM index between the two. Cool. Right. Back to business. Okay, so we've looked at sort of the resize methods that we have for Mr. Goldblum. They don't seem to be behaving consistently. So let me see. Let me see whether or not this guy would require. Would require rather the first Jeff. So I wonder if this guy, the PNG, would need to be cast to a different data type. It looks like it still has the same issue. Or this is just playing around. I wonder if interesting. Let me. Okay, so let's try something else. Let's try preserving. Let's try preserving aspect ratios. So we've determined that we should probably have ints rather than floats if we want to plot things with IMShow. Let's pull this guy down again. And let's do preserve aspect ratio. Preserve aspect ratio equals true. Interesting. Cool. So you can see here, this guy looks a little bit squashed. This guy doesn't look squashed, but he does have really obnoxious axes. There we go. Does look squashed and looks very pixelated. Even more pixelated. Much better. But there was an error message, I thought, that happened before our plot.axis. I wonder what that error message was. But yeah, I thought I saw something saying tf.cast, in which case that would be problematic. Because I don't think, let me check again. Yep, there's no tf.cast in TensorFlow 2.0. For folks, and let me check the chat just to make sure that, whoa, lots of people. So, and also screenception. So for TF 2.0, we have a number of symbols, aggregation method, assert, attrib value, over 3,000 that are in the process of being migrated to alternate names, keeping the same name or being deprecated completely. And the mentality behind that was that the original TensorFlow 2 or the original TensorFlow API was very extensive. It was redundant. So it had a lot of functionality that was basically taking care of the same thing. Actually, it might be a little bit easier for me to take a look at the camera while I'm talking about this. Cool. So yeah, the original TensorFlow API was very, very extensive, over 3,500 symbols. A lot of them did the same things. They were very unintuitively named. A lot of them were kind of cobbled together. We had a ton of stuff in contrib, tf.contrib, that was sort of bestowed on the API as a gift, which is awesome. But without any sort of support plan or sort of testing or any sort of plans for doing integration or long-term support. And that meant that tf.contrib kind of ended up being this big, big basket filled with stuff that maybe worked in 1.4 but didn't work in 1.12, or maybe worked in 1.12 and maybe won't work in 2.0 yet. And so tf.contrib was viewed to be just something that should be deprecated, and the bits that were useful to people should be supported and found a way to migrate. So we now have a special interest group called add-ons, which is open to the community. They have a mailing list. They created an RFC, which is a request for change. And they're in the process of taking everything that was in tf.contrib and finding a way to support it, to convert it to 2.0 style syntax, and to migrate it to new locations within either the add-ons repo or within the TensorFlow API proper. So if you have deep, passionate feelings about any of the functionality that is currently existing in tf.contrib, I strongly suggest you take a look at the add-on special interest group and adopt that symbol like a puppy, nurture it, build a support plan for it, and then we can all kind of find a way to make it migrate to the to either add-ons or the TensorFlow API. So mentality behind, sort of motivation behind mentioning that, right, is the idea for TensorFlow 2.0 is to focus on a consistent syntax, API design that feels coherent, that feels like it was well thought, and that the functionality is intuitively named. And given that, everything should be consistent. So if you have a float coming in, or like a collection of functionality, so like all of these resize calls, it shouldn't be that you can use floats with some of them, like float 32s, and then other ones require int 32. And for some of these tensors, I think, or for some of the methodology that I was showing, it doesn't seem like it has a consistent requirement for the input data format, and that's something that I should address. 3 of those resize methods required int 32 to display properly, and 1 doesn't. And then also you have to prepend resize method dot whatever with tf.image, and that's not exactly intuitive. So it looks like there's still some work to be done for that particular bit of the API, for the resize portion. And with that, I'm going to dive back into the Colab notebook. Cool. Hopefully. Share. And screenception. Brad. Okay, back to my notebook. We've looked at the resize images. That is really clunky to me, that you have to cast types to resize and then specify a method. That feels very ugly in terms of a one-liner. Let's try transposing things. So hopefully this would be a little bit easy. Or actually, wait a second. I want to try something else. So here we've got an image that makes sense. What happens if I do that? Attempt to convert a value none with an unsupported. That's not an intuitive error message. Ideally, I would be able to see something to the effect of this should be greater than 0, not -1. So this, yeah, that error message needs to be improved. What happens if it's a JPEG instead of the PNG? Let's try this. So at least that's better, but that's still okay. So that's another complaint that I need to make about how to improve error messages. For JPEGs, if I put in dimensions that don't make sense, so if I say, "Hey, I want my height to be negative," we get something that looks intuitive, right? Output dimensions must be positive. Cool, that's great. If it's a PNG though, we got that really wonky thing talking about none types. So let's see what happens if I do this. Okay, there's a line that feels like it makes sense. What happens if I do preserve aspect ratio? Wait, what? Oh, that's weird. Okay, that's cool. So this again, what's supposed to happen here is that there would be an image that is 1 pixel tall by 400 pixels wide, and that was the case whenever we did that, right? Like it's just a straight line for Mr. Goldblum. But whenever you do preserve aspect ratio, it doesn't seem to know what to do with itself. So that might be something to investigate. It's probably, an artifact of the math that's required for this guy. But it's still kind of counterintuitive to see, right? Like I would not expect to see these two squares when specifying that I want a resized image for 1 by 400. Cool. Cool. Oh, that's sweet. Okay. Moving on. Let's try flipping images and seeing what happens. So for Jeff and our Jeff vectors, right? I want to display them all at once. So plot figure, plot.imshow, tf.image, and what's the fun one? Rotate. So we're going to try to rotate them by 90 degrees, and it'll be for every Jeff that we have. And K equals -1. And K is just kind of how many times you want to rotate it 90 degrees, and it should be in the direction that you select. So this should be like a right rotate, I think, as opposed to a left rotate. And then the axis should be off because, like I said, it's annoying. So let's see what this does. Rad. Okay, cool. So there are our 4 Jeff images. It looks like they've been rotated to the right. If I wanted to make them upside down, do that. I turn around. And this should also be identical to flip up down. So let's see if that's the case. Flip up down Jeff, and there shouldn't be any sort of special thing that I have to include. Yep. There we go. Rad. Okay. And the other nice thing about this, well, I mean, nice in terms of I didn't have to do anything special, but sad in terms of, I would ideally like to have similar behavior from every call. I didn't have to convert this from a float 32 to an integer. I didn't have to convert it to a float 32 rather. I was able to keep the same format and everything worked the way it should. So that's convenient for me, but not exactly ideal in terms of having behaviors that are similar. Let's try transpose. I'm kind of interested to see what this looks like transposing a matrix. Yeah, so it didn't rotate. It didn't rotate because so he's looking that direction. So Jeff looking to the right, whereas in the original image he was looking to the left. But what it did do was, just like transposing a matrix, it took top right and put it in bottom left for each one of the pixel locations. Cool. So transpose works up and down, random, flip, up, down. The other nice thing is that no matter what, PNGs or JPEGs, all of the calls seem to be doing what they're supposed to. Rad. Okay, so it looks like the sort of flipping, rotating, and transposing operations are behaving nicely. Let's try color spaces. So there are several ways to do color operations on images. You can either do them on batches or you can do them individually. For TensorFlow 2.0, since there's a focus on eager execution, which means that everything feels very Pythonic, you are able to you're able to type in a command and get a response back immediately. It feels what's the word for it? If you're not a fan of delayed gratification, and I certainly am not, it makes it a lot easier to deal with neural networks, to deal with tensors, and to kind of understand what's happening as you're building and creating your graphs and architecting these networks. So historically, I think some of these guys had only been able to work on batches. With 2.0, you should be able to do them on individual images. So just taking a look at the overview of all of the tf.image symbols. So we've got some for adjusting brightness and contrast, but I think that those are down further a little bit in the notebook. Adjusting hues, saturations. Cool. And then for these guys, with the weirdest acronyms, I don't understand why acronyms are so... Outputs a tensor of the same shape as the image's tensor containing the RGB value of the pixels. The output is only well-defined if the Y values are in ranges, or Y value in images are in 0 to 1. Also note, improve documentation. Improve documentation to say what this is actually supposed to do. And then YUV, outputs a tensor, UV values. Yes, this also needs better documentation. But regardless, let's try to see how it works. Cool. So tf.image.rgb to YUV, and the transpose stuff didn't have to deal with type recasting. So let's see if this guy doesn't have to deal with it either. Nope, that is a big nope. Cannot convert provided value to eager tensor. Provided values, requested data type, and 32. Okay, cool. Sounds like I need to do some recast. Okay, so tf.dtypes.cast Jeff's, this should be the second one, and the float value. Cool. Try this again. Okay, cool. So I've got I've got a numeric array. Looks nice. Let's see if I want to show it. So plot.im show. Oh God. Okay, that looks atrocious. But I mean also cool. That looks like a punk poster from the 80s, right? Like I could imagine going to go see a show that looks kind of like this. But yeah, no, not ideal for the sort of image that we would want to see of Mr. Goldblum. So let me try converting this. So okay, so to something else. So tf dot image vert image. Or actually, so we've got the RGB. Let's try casting it again into ints. That should be able to solve the problem. So types cast, stay consistent, and then that parentheses, and then comma tf.int 32. Does that work? No. So it's looking for a D type again. Let's try. Beautiful. Excellent work. Get rid of the axis. Perfection. Okay, so that looks a little bit nicer. Beautiful. Beautiful, beautiful. But that is not beautiful at all. Having to cast to a 32 float, and then also, yeah, that does not look as straightforward as it could be. And I wonder if it would make more sense. So whenever you ingest images, whenever you sort of define them as tensors, you can specify what type that you want. So when we pulled them in, the D type was an int 32. I could have pulled them in as a float, and then everything would work the way that it was supposed to. So I wonder if that would just be a best practice to recommend, is since so many of these image operations require it, to just pull them in as that in the first place. But anyway, okay, so RGB to YUV, let's try, what is this yick? What does it do? Cool. So green as opposed to blue. And then RGB to HSV. Beautiful and blue. Cool. So actually, let me share the link for this guy. Get shareable link. Anyone with a link, save. And then put it in the chat window. Whoa. Hey, Ron. So that people can see. So I will stop sharing so that there's no longer screenception. Hello, everyone. Yes, if you did have GPU acceleration for your Colab notebook. I think that the image operations would be GPU accelerated. I am not using a GPU enabled notebook right now. Though Colab does offer TPU support and GPU support for free. So if you haven't ever played with Google Colab before, it's colab.research.google.com. You can use it for free. You can sort of try out different packages. You can install things if you preface it with a little exclamation point. So any shell operations are supported that you would typically use in a Linux environment. And you can also share those notebooks with anybody who has access to the link. So it's really cool. It's a great research tool. It's a great prototyping tool. It's a great way to try things without necessarily borking your home environment. And it also comes with a lot of data science packages pre-installed. So things that you know and love, like NumPy, SciPy, Pandas, Matplotlib, TensorFlow, I think 1.13 now, though maybe I think 1.13, because they just added CUDA 10 support for external Colab. But all of it's kind of freely available and ready for you to use. Another nice thing, you can also sort of hook up your Google Drive instance, because one of the sort of terrible things about using these sort of transient notebook environments, right, is that the data that you ingest whenever the virtual machine resets itself is sort of also recycled. So you don't really have persistent data access within the notebook. But if you do hook it up to your Drive instance, you're able to have kind of a more long-lived place for your data. But strongly recommend trying Colab if you haven't already. Any other question? I didn't see any. Cool. So if I go back to, cool to you too, Ron. If I go back to, share, this guy, this was intended to be a friction log. Friction logs, and we're about 6 minutes away from 11 p.m. and I want to be respectful of everybody's bedtime schedules, and also whether or not they, so bedtime schedules, and then also, you know, it is a Saturday night, and I am aware that most people probably want to be out doing cool things, but I think this is cool. So I'm glad that everybody's here tonight, and I think that it's awesome that you want to learn more about TensorFlow 2.0 and tf.image. But friction logs are sort of, if you're feeling a little bit uncomfortable about filing bug reports, or about sort of logging detailed errors if you're not sure that there are errors, friction logs are a great way to kind of get around that unease. What they are sort of stories of your experience and how you feel about using a product. So they're very task focused. So I wanted to transpose an image, and how did it go for me? And then for each step of the process, you would say, yay, this is awesome. So this is fun, it's good to do, or this is a little annoying, I'm frustrated, or I would quit if this wasn't my job. And then once that is over, you create the log, you sort of share it out, and the people who create the product have an idea of what bits and pieces they can improve upon in terms of user experience, in terms of making the API better, or more streamlined, that sort of thing. So going back to this notebook that I had used before, right? The piece for this, probably pretty red in terms of friction loggy. The piece for figuring out what different kinds of typecasting I need to do in order to make this display, that's pretty red. But then again, the being able to do just the flipping, rotating, and transposing operations, that was incredibly straightforward, regardless of data type, right? So PNGs, JPEGs, they all seem to work nicely, and they preserved kind of the original state of the image as well. Everything looks very crisp, very clean, and sort of easy to use, very straightforward and simple. Another thing that I could include, right, is that flip left right, that's pretty intuitive as a name. RGB to YIC, that is, you know, I'm sure that there's a cohort of people that know what YIQ is, but it sure would have been nice if the documentation also sort of reflected what that functionality should be. At least like a link to a Wikipedia article so I could read up and find out what was going on. So I'll make sure to include that as well, that the documentation should be improved. And I also want to make sure that everybody knows if you ever are reading about a symbol in TensorFlow or in any other API, if any portion of the documentation doesn't make sense or isn't isn't understandable to you, file an issue. Documentation is code. And if something isn't okay or if something could be better explained, I am sure that the developers would be excited to hear it. So make sure to file docs bugs if there's anything that doesn't make sense. And the other nice thing, if you file an issue, like a specific issue about, hey, this symbol, I read it and I did not understand what was going on. Why was there not a code sample? Why was it not well explained? Then that means that it's a ticket that somebody has to pay attention to. And the, you know, like squeaky wheels get grease, it'll probably get resolved. So again, if you see anything that doesn't make sense in TensorFlow docs, please make sure to file a bug. Cool. So with that, it is 11 p.m. I'm going to stop sharing and say hi to folks this is the Google AI library. I'm not sure if everybody got to see it before, but it's kind of amazing. It's really cool. Even for a Saturday night, it's very cool. And I am so delighted that so many of you decided to spend time learning about TensorFlow tonight. So thank you for saying that. I don't know how useful this was to watch me work out frustrations on a laptop, but this is so that's what I do. But yeah, have a good night, and I'll see you again next week maybe. And feel free to send suggestions, to ask questions, and to also play around with the notebook that I linked, and let me know what's cool and what's not. Thanks.